Peace be upon you all, and good afternoon, ladies and gentlemen. Alhamdulillahirabbil alamin. Assalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in, amma ba'du. A warm welcome to the Dean of the Engineering Faculty, Universitas Islam Malang, Dr. Ena Marlina, Master of Engineering, respectable or respected keynote speaker, Professor Dr. Hua Shushu, Honorable all the faculty members in Universitas Islam Malang, international seminar and forum group discussion participants who are joining this meeting, and all the dedicated committee members. First, let us thank our God, the most gracious, who has given us blessings so that we can come together in this auspicious gathering. Let us not forget to send our sincerest blessings and peace be upon to the Prophet Muhammad sallallahu alaihi wasallam. Ladies and gentlemen, and respected participants, welcome to the international seminar and focus group discussion organized by the Faculty of Engineering Universitas Islam Malang with the theme Integration of Semiconductor and Magnetic Material for Spintronics and Opto-Spintronics Applications. I am Ita, and it is my pleasure to serve you as Master of Ceremony today. Without further ado, let us officially start this seminar. We are excited to invite you to join this meeting. Thank you very much for coming, and I always look forward to your active participation in the series of the meeting.
Jangan halang ke nasibmu, bangkitlah hai bangsaku, usapkan hati wahai tanah airku, cintamu dalam imanku. Jangan halang ke nasibmu, bangkitlah hai bangsaku. Indonesia negeriku, engkau panji martabatku.
you for your participation. Please be seated. Next, we will listen to the recitation of Nuril Anwar. Salawat Nuril Anwar. Ladies and gentlemen, the next opening remarks from the Dean of Engineering Faculty of Universitas Islam Malang. Please join me in welcoming Dr. Ena Marlina. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin wassalatu wassalamu ala asrofil anbiya'i wal mursalin wa ala alihi washabihi ajmain, amma ba'du. Good afternoon, respectable Professor Dr. Hua Su Shu, Dean of the Research and Development Office and Professor in the Department of Applied Physics, National Pingtung University, Taiwan, respectable Vice Dean, Chair and Secretary of the Civil, Mechanical, Electrical Engineering, and Informatics Study Programs, respectable Bapak dan Ibu lecturers of the Faculty Engineering, and my beloved students of the Faculty of Engineering. I would like to express my gratitude to National Pingtung University NPTU Taiwan, especially to Prof. Shu, for his presence at Unisma today. This reflects a strong commitment to fostering existing international collaborations to advance education, research, and innovation. The essence of academic growth lies in the spirit of collaboration, and today forum group discussion is a testament to this. Through the forum group discussion, we have the opportunity to learn from each other, inspire fresh ideas, and strengthen the bonds between our institution. I'm confident that this FGD will pave the way from innovative initiatives, impactful research, and lasting friendship. On the occasion, I invite all academicians of the Faculty of Engineering to actively participate in the collaboration between Unisma and NPTU. Once again, I would like to sincerely thank for everyone for their presence and dedication in making this event a success. I hope this forum group discussion session will be fruitful and memorable. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you for your speech. Let us now seek blessings for this event through a prayer led by Mr. Abdul Muta'ali. Please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Mari kita bersama-sama berdoa semoga acara ini membawa barokah. Bismillahirrahmanirrahim. Allahumma shalli ala Muhammad wa ala ali Muhammad. Walhamdulillahirabbil alamin. Hamdan naimin, hamdan syakirin, hamdan yamau mazidi mazidahu ya rabbana lakal hamd. Kama yanbaghi li jalali wajhika wa 'azimi sultanik. Raditu billahi rabba wa bis islami dina wa bi Muhammadin nabiyya wa rasula. Allahumma ya Rahman ya Rahim irhamna wa jami'atina unisma wa jami'i talamidana wa durriyatina. Allahumma ya Ghaffar ighfir lana dunubana wa dunubana jami'atina unisma. Allahumma aftah abwabal jannah wa abwan nikmah wa abwal barakah. Allahumma inna nas'aluka ridhaka wal jannah wa na'udzu bika min syakhatika wan nar. Allahumma rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzaban nar. Wa adkhilna jannata ma'al abrar ya aziz ya ghaffar ya arhamar rahimin. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa sallam. Alhamdulillahi rabbil alamin. Al-Fatihah. Iya kana butuh yang nasta'in. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Continue with handing over souvenirs by Dean of Faculty Engineering of Universitas Islam Malang, and then continue with documentation. Please welcome. Ladies and gentlemen, as we have finished the opening ceremony for this meeting, it is time to continue to the main agenda. We have here the international speaker, Professor Dr. Hua Sushu, Dean of the Office of Research and Development and Professor in the Department of Applied Physics, National Pingtung University, Taiwan. And the moderator, Ahmad Faruk Al-Hikami, Master of Science, who will guide this session till the end of meeting. So, without further delay, allow me to give the floor to the moderator to handle the agenda. At your convenience, Mr. Faruk.
Assalamualaikum warahmatullahi wabarakatuh. Okay, good afternoon everyone. So, I will lead this focus of discussion as your moderator. And for this occasion, the language will do it with two languages, so Bahasa and English, because some of the audience are students. So Professor Su, I would like to little bit introduce our students here. So there are three departments of our Faculty of Engineering, and there is a Mechanical Engineering Department, Electrical Engineering Department, and Civil Engineering Department. So in this occasion, they are hoping to have some big picture of the National Pingtung University, and also the opportunity of the scholarship and some of the collaborations between Unisma and NPTU. there are some research field that really link to your research area. If not that, there is some electrical students, they're also willing to have some opportunity in the College of Computer Science. So I think NPTU also have it, right? College of Computer Science. So there are some robotics and also computer science field. So without further ado, I would like to introduce our first speaker. So he is Professor Hua Su from National Pingtung University. So you can search, the university is quite renowned and good in the Pingtung, is the south part of Taiwan. So actually, Professor Su, we have 3 lecturers graduated from Taiwan University. So myself from National Cheng Kung University, and Ibu Ismi, she is graduated from National Central University, and another one, the lecturer of electrical department, he is graduated from National Sun Yat-sen University. So we are very familiar with Taiwanese culture and hoping our students can continue in his future career in Taiwan. Okay, so the current positions of the Professor Su is Director of Magneto-Optoelectronic Labs. So I think if you search, this lab is quite a big, I think big research group, you know, the Magneto-Optoelectronics Lab. And he is also Dean of Research and Development Office. So I think this is very good opportunity to us to know the research and development in the National Pingtung University. And he obtained PhD from Department of Physics at National Cheng Kung University, Taiwan. So I graduated from NCQ and Professor Su also. So we are both from NCQ, Taiwan. And he published a lot of paper. So if you search his name in Scopus, he published 80 papers, 80 papers, Scopus, with the total H index is 19. So I'm hoping there's one alumni of Unisma could be like your future students, Professor, because this is a very big opportunity for us. Okay, without further ado, please, Professor Su, the time is yours. Okay. Can you try the pointer first?
Okay, maybe I will check. Okay. It's fine. Maybe it's okay. Let's try, Professor. Okay. It's fine. Maybe I can stay here. I can stay here. But it's fine. It's fine.
I can operate your PPT. Just say
I
next.
I can stay here to control my PPT. Okay. Good afternoon, everyone. Okay, it's my honor to have the opportunity to give a presentation related to the RD research topics related to NPTU, and to give a very short introduction about my research. Because I think today the most important thing is not to talk too detail about my research, but I just want to encourage you in the future, we can have more collaboration each other. And if you search my name in Google Scholar, you can find I publish some papers, but very diversity, because I enjoy to work with different field scientists and the different countries. For example, in my presentation, publication, I think I published almost 20 papers together with different countries' scientists. For example, Russia, Thailand, Czech Republic, Poland, and France, and New Zealand. Okay, so I hope in the future, okay, we can cooperate with each other and to publish some interesting results. I think maybe the yes, connection is not good. or I can use this, use USB to somebody. I think the connection is not. I think, yes, I can use yes.
Pakai laptop jenengan, Bu. Enggak bisa. Pakai komputer.
Ini sudah stabil, Bu.
Tadi ada pointer di situ.
Ya, ini apa?
Yes, please. Sorry for the technical problem. Okay? And before I give my presentation, I also want to thank my Indonesia friend. Okay, he take maybe 30 minutes during the lunch time to let me to look over the environment of the Unisma. Okay, I'm very impressed, not only for the laboratory, but also for the student cafeteria. Because in the student cafeteria, I see the lecturers, professors, students, they can sit each other to enjoy their lunch. I think it's very, very good. I always mention, because a lot of friends, they taught me the Indonesia people are very good for cooperation. In the beginning, I don't know why, but when I visit Indonesia, maybe I know a little. Because the Indonesia is a multicultural country, and you respect each other. Senior, junior, student, lecturers, you can sit together and to enjoy and to talk. Okay, I think it's born from nature. Okay, to very humble and easy to cooperation. So I really hope in the future we can have more opportunity to learn from each other, to have more cooperation. So sometimes to publish paper is not only the purpose. Okay, to learn from each other is more joyful, especially for our long life. Okay, I'm sorry, maybe another file? Yeah, another file, sorry. The one is RD file. RD file. Here, RD file.
HP laptopnya di extend dulu.
And then the other file is yes, is talk in Nelocam. Talk in Nelocam. This one. This. RD first, thank you. Okay, so, okay, good. So, let me start our today's presentation. In the beginning, I will give a short introduction about some keywords about R&D in MPTU. Actually, it's some keywords in our MPTU R&D. Okay, we have computer science college. So the iRobot, VR, AR, MR, AI is our research focus of our computer science college. And we also have a college of science. Okay, we will focus on the new generation electronics. What is new generation electronics? Also related to AI. Because AI is a very hot topic. Somebody calls AI revolution. Okay, because why AI need new generation electronics? Because AI is very energy consumption. Okay, so but nowadays the electronics is move the charge from one side to another side, and they call 0 and 1. And if you want to move the electron, okay, you will need the energy. You will need the energy, okay? And if you want to do more AI calculation, okay, you mean that you need more energy to do the 0, 1, 0, 1, okay, process. So a lot of scientists, they start to worry about if the AI development is continue growth, it must need some new generation electronics. Okay, so my another topic is related to spin. What is spin? The electron also not only have the charge properties, but also have spin properties. Okay, and if you use the spin properties of the electron, sometimes you don't need to move the electron. Okay, you just to change the spin of electron. Okay, and then be called 0 over 1 over some a lot of different state, 0.5 or negative 0.5, only use the electron spin. Okay, so it will be considered more energy consumption, less energy consumption. So it means the new generation electronics. And also the energy is also important. So actually the AI, iRobot, new generation electronics, and the energy, all these topics seems different topic, but actually it's all the similar direction for our future human life. Okay, so it's some research work of our MBTU RMD. And we have a VAR research center in MPTU. So if some students or some professor you are interested about the VAR, okay, research technology, you also can visit our university. And because I am the dean of RD office, so my another mission is to be the window, contact window between the university and the industry. So we also have some company, Fastcom. Okay, they are focused on to produce the VAR glass, the VR glass. So and it need the talent of the electronic engineering or the mechanical engineer, okay, together, okay, and optical engineer together. So if you are interested, okay, you can join such kind of research project. And we also have the iRobot on laboratory, okay, because in the future, the industry, okay, and I think in Indonesia it's good because a lot of young men, but in Japan, in Taiwan, in Korea, our birth rate is decreasing significantly. So it's very difficult, okay, to get the young human resources or young talent to work in factory. So now, for example, in Taiwan, every graduate student, they have at least 4 opportunity to work in company. Okay, because no young talent. So that's why now a lot of company they try to become more internationalized. Okay, they want to encourage the young talent from different countries. okay, to work not only in Taiwan, because sometimes they also have some company, okay, in different countries. So that's why we need the iRobot, because we can realize the unmanned, okay, factory. Okay, so this is our another research focus. And there is in our college, okay, we have a lot of instrument or equipment to fabricate the new generation electronics. And of course, we also try to collaborate with the company and the industry. In Taiwan, okay, we have two different, the government, okay, encourage us to choose our direction. One direction is, maybe you have heard of the National Taiwan University or National Cheng Kung University. Okay, our government encourage them to focus more fundamental research. But in Pingtung University, okay, our government focus us not only the fundamental research, but also try to cooperate, okay, with the industry, okay, to do some applied research. So that's why our department is not a department of physics, it's department of applied physics. Okay, we don't do the research about the astronomy or gravity wave. Is also very important topics. But in our department, we don't do such kind of research. Okay, we focus on semiconductor or material science or electronics research. Okay, so also welcome to visit us. So we also have some joint laboratory with different countries, because our National Science and Technology Council, they also encourage to have the joint research proposal with different countries. For example, I have experience to apply the Taiwan Czech and the Taiwan Poland, and in the future maybe Taiwan France, Taiwan Indonesia, join the research. But if you want to apply such kind of project, the most important thing is we need to cooperate together now, because when they call for proposal, we submit a proposal, but without any publications together. Okay, it's just a proposal. But if we can start our joint research now, from now, and we have some publication together, then we apply the joint proposal. Okay, we can have higher possibility to earn the proposal grant. So also welcome. Okay, it's our some exchange students. So in our RD office, okay, we also provide some not big budget, but it's I think enough budget for the start fund to have the international cooperations. And we also provide some project to invite some international scholarship to visit us to do the joint research. And we also have a double degree program. Okay, for example, one of my student is from Thai. When she studied in undergraduate school, he be an exchange student in my laboratory. And her professor, okay, Professor Nun, okay, she come to visit her student, and we have lunch together and have some discussion. And he shared his research experience related to photocatalytic to me. Okay, and I share, why not maybe we can integrate the semiconductor with your experience. So we work together, and then her student continue to study the master degree. Then finally we publish a paper. I think it also in a very good journal. We are very happy. And the citation, we published paper in 2022 maybe, but now the citation is more than 15, because it's a new idea, because we integrate two different research fields. So I think that's a good example for you in the future. Maybe we can have more cooperation. Okay, so please change it to another file. And I think then I will just maybe 5 to 10 minutes, just a very short introduction. My research focus in my laboratory. Okay, this work just I mentioned, I cooperate with the Thai professor. Okay, her research field is related to photocatalytic, and my research field is related to semiconductor. So we integrate the two concepts together. So that's why I chose this topic to share with you. It's an example for the international collaborations. Okay, and in the beginning when we talk about Taiwan, okay, some people will think about TSMC. Okay, and TSMC is good. Okay, but some people also say that Taiwan is the most dangerous country in the world. Okay, but don't worry, we are safe. So right, Taiwan is safe, right? Agree? Yeah. So don't be too nervous. Okay. And it's in Pingtung. Okay, I think Pingtung is a very convenient city. I think it's similar to Malang, but Malang is bigger. Okay, Malang is bigger, but Pingtung I think it's a 30-minute city. What is 30-minute city? It means you can use only 30 minutes, can do everything. It's very convenient. And sometimes in some countries, they like big cities, like Shanghai, Tokyo, or Jakarta, Taipei, big cities. But some people, they think sometimes the 30-minute city is better to live. Okay, if you want to do some business, just take an airplane or high-speed rail train to the big city is good enough. So it's a 30-minute city, and a lot of delicious local food. Okay, so I'm not an expert in physics. I'm also an expert in local food. So that's why I am so interested about the student cafeteria. Okay, so welcome all of you to visit us. Okay, we also have a delicious seafood. Then. I just want to show, just I mentioned, the new idea for us is spin. So whatever your research field, okay, you can try to put the electron spin, okay, in your research. Okay, if you don't know how to do it, maybe we can cooperate with each other. Okay, in the beginning, my focus is spin electronics. Just I mentioned, we do not move the electron. We control the spin for electronics. But this research is why we put the spin properties with the photocatalytic experiment. And some people also ask me, is it possible to put spin in battery or in solar cell? The answer is yes, it is possible. And already has some very high impact factor journal publish such kind of research result because it's new. And a lot of professors also discuss with me how to integrate the spin property in their research. Okay, because they also mentioned, oh, in my research field, the competition is too high. Okay, because when I do a solar cell, the efficiency is 21. And the next month, another paper say they are 23. So they need to competition the efficiency. But if they add the spin property, it means it's new. It's new. Okay, so they also can publish some good journal. Okay, so that's the spin properties. And it's a Nobel Prize. Maybe you think, oh, spin is too difficult for me. No. Now in everyone's computer, you already have such kind of devices. In your hard disk reader is use the spintronics concept. So spintronics concept, spin electronics is not only for research, it's only for real product. Okay? So this kind of result also been awarded for the Nobel Prize in 2007. Okay, just as I mentioned, we don't want to move the charge as the 0 and 1, we control the spin. We control the spin, okay, to do the new generation electronics, okay? And today, I just show some, because I know the shortage of time, I just show one page of my then result cooperate with the Thailand professors, okay? We grown the zinc oxide nanowires. Zinc oxide is a semiconductor. I think a lot of professors know zinc oxide material. Okay, it's a very typical or classical, or you can see it's old, okay, semiconductor. Okay, but old means stable. Okay, I know recently a lot of professors, they try to publish some very novel 2D material or something, but sometimes 2D material is not air stable. Okay, zinc oxide is old but classical, but stable, or stable. Okay, but some professors say, but zinc oxide already published a lot of paper. It's not a new material. If we do this research, it's very difficult to publish high impact factor journal. But we say it's fine. We can put some spin into it. How to put spin into it? Not too difficult. We try to dope the cobalt on the zinc oxide surface. And of course, we do some special treatment, okay, to make the cobalt become the cobalt +2 and the dope in the zinc oxide surface to change its band structure, change its properties, okay? And we also use the synchrotron radiation technique to check it. And we have a very close relationship to cooperate with the synchrotron radiation center in Taiwan or in Japan in Spring A. Okay, the Thai student in our laboratory also go together to Japan Spring A to perform the synchrotron radiation center, the experiment. Okay, we use the synchrotron radiation technique, X-ray absorption spectra, to confirm, okay, the cobalt to replace the zinc on it. And then we can find, after we dope the cobalt and then we integrate the spin with zinc oxide, okay, then the photocatalytic efficiency can be enhanced by magnetic field, Okay, so it's not very difficult research, but new. In our research field, the concept is not difficult. In the Thai professor's research field, to make a zinc oxide nanowire is not difficult. And we also cooperate with the synchrotron radiation scientist. Then we publish this paper, okay, in ACS Applied Material Interface. The impact factor is about 10. Okay, so I think it's just an example for all of you of how to integrate the spin with semiconductor material. Maybe can for electronics, or can for photocatalytic material, or for energy, or for everything, And why the put spin into the semiconductor become more and more important? Because recently, I think some people may know the silicon photonics. Because now we always talk about electronics. But just I mentioned, electronics, the transport, okay, the signal is very, very energy consumption. So recently, TSMC, Taiwan Semiconductor Manufacturing Company, they start to do the silicon photonics. Why? Because to transport the information using the photonics is less energy consumption. So recently our group also tried to use the electron spin to control the photon polarization. So we recently also published a paper with friends. Okay, they grown their thin film, and then we use our concept to integrate with them, and we published paper to control the electron spin and to control the optical polarization. So I think I can stop here. If you have more question, we can have more discussion. Okay, I just let you know the international cooperation, I think, can have a win-win situation. And we can learn from each other. Okay, and my research focus is the electron spin. Okay, so if you have any idea, we can have more discussion. Okay, so thanks for your attention. Thanks.
Okay, big applause to Professor Shu. Yeah. Please have a seat, Prof. Yeah. Oke, saya akan terjemahkan sedikit ya, dalam arti bagaimana hubungan antara penelitiannya Profesor Shu tentang spinning of material kok bisa ke elektronik. Nah, secara singkat bahwa part-part elektrik kayak hard disk atau USB kalian itu kan ada materialnya. Itu nggak mungkin hanya besi kan. Nah, bagaimana material itu mentransfer elektron? Kenapa kok elektron? Karena listrik itu butuh jalan. Kenapa kita memilih tembaga? Karena tembaga itu bisa mentransmisikan elektron. Nah, penelitiannya Prof. Su ini mencari material-material baru. Ternyata ada istilah spin. Spin itu apa? Kalau magnet ada kutub utara, kutub selatan. Kalau kamu dekatkan kedua magnet, magnetnya kan mendekat. Tapi ketika dia berlawanan arah, maka dia akan muter. Nah, dia akan berputar. Pertanyaannya, material apa yang punya karakteristik spin? Oke. Kayak penelitiannya tim riset material, seperti ada beberapa mahasiswa di sini. Karbon itu mengikat oksigen. Oksigen itu negatif. Dia mengikat hidrogen. Hidrogen itu positif. Kenapa kok terjadi ikatan tarik-menarik seperti penelitian Bu Ena juga? Jadi ada magnetic field di situ. Atom oksigen dengan atom hidrogen tarik-menarik saling berikatan. Ketika ditambah dengan atom yang lain yang memiliki ikatan positif, dia akan ketarik juga. Kok bisa ketarik? Berarti ada magnetiknya. Namanya magnet. Ya, kalau sesama positif negatif maka dia akan tarik menarik. Oke, itu dulu ya. Terus hubungannya dengan masa depan itu apa? Oke. Masa depan itu bagaimana kita mentransmisikan elektron dengan daya yang rendah. Energinya rendah. Kenapa kok butuh energi rendah? Laptop selama sekian tahun akan semakin kecil. Ya kan? Kok bisa kecil? Karena butuh material yang sedikit tapi dia transmisikan elektron secara optimal. Nah, apa saja yang dibutuhkan? Mechanical dan electrical ini saling keterkaitan. Oke, jadi elektrik tidak melulu daya yang dibahas. Itu untuk orang power. Tapi orang elektronik, bagaimana kita bicara material? Karena kita bikin. Kalau kita kan beli hard disk dipakai di komputer, enggak. Taiwan itu bikin hard disk, bikin adaptor, bikin USB driver. Di dalamnya ada material. Jadi harus saling kombinasi antara orang material dan electrical. Kita tidak bicara big picture lagi ya. Kita tidak bicara bagaimana merangkai hard disk dan laptop, enggak. Bagaimana kita mentransmisikan elektron dengan daya yang rendah sehingga listrik itu bisa stabil gitu. Intinya gitu ya. Jadi penelitiannya gitu. Nah, sebelum saya ini secara fundamental things penelitiannya Profesor Su. Nah, kalau misalnya saya ingin S2 di NPTU, oke, saya beri glance atau key point ya. Jadi bidang apa saja yang bisa saya kerjakan? Untuk yang electrical, kalau misalnya dia based on-nya informatics, Anda bisa memilih bidang AI. AI-nya kemana? AI-nya bisa ke robot, bisa ke bidang energi, bisa ke elektronik. Semua itu butuh AI. Oke, Pak, saya tertarik big data, bisa big data. Nanti mungkin Prof. Su akan memberikan rekomendasi profesor mana yang kita bisa applied on, ya. Terus kalau saya bidangnya material, karena di mechanical engineering itu kan tidak hanya konversi energi, tapi juga bagaimana material penyedia energi itu bisa relate-nya ke energi. Seperti doping. Ini doping itu bahasa Inggris. Komposit penelitiannya beberapa mahasiswa kan ada yang biokomposit antara SiO2 ya, between SiO2 dengan apa? Silika dengan karbon, dengan natrium, kalsium, itu juga doping namanya. Nah, itu sangat relate dengan penelitiannya Prof. Su. Nah, tinggal dikembangkan. Setiap material itu pasti punya medan magnet karena ada kutub positif dan negatif. Tinggal bagaimana mengukurnya. Nah, itu penelitiannya Prof. Su ini, expertise di bidang spinning elektron. Oke, itu ya. Terus yang informatika, Pak, saya itu pengen coding atau apa. Ada teknologi VAR ini yang sedang dikembangkan oleh NPTU. VAR itu kayak kalau kamu main game, real game 3D, pakai kacamata, terus kamu bisa jotosi orang lah, itu teknologi VAR. Jadi pada imagingnya kamu jotosi orang, pada realnya kamu hanya duduk, gerakan tanganmu aja, tapi pakai kacamata. Itu teknologi VAR. Pak, teknologi VAR itu dilihat dari mana saja? Dari materialnya bisa, dari codingnya bisa, dari database bisa. Itu semua field itu harus diisi masing-masing expertise. Nggak bisa satu orang itu menguasai semuanya, nggak bisa ya. Jadi kamu harus menguasai salah satu, either material, informaticsnya kah, atau codingnya. Nah, yang terakhir nanti Anda bisa tanyakan how to apply. Bagaimana Pak? Saya itu pengen Pak kerja di TSMC. TSMC itu saya kasih tahu BUMN-nya Taiwan. Dia itu supplier nomor 1 Apple dan supplier nano chip. Jadi nanomaterial yang ukuran paling kecil. Kalau kamu tahu komputer yang pakai Ryzen itu loh yang terbaru, Intelnya tapi kompetitifnya itu Ryzen itu pakai nano chipnya dari TSMC. Jadi TSMC ini future karir lah kalau orang kuliah di Taiwan itu pasti pengennya ke TSMC, ya. Itu BUMN-nya Taiwan. Oke, namun tidak semudah itu Ferguson kalau nggak belajar. Nah, harus belajar, oke. Nah, oke, Professor, sorry. So I just introduced to very easy language to the students. Okay, how to collaborate? The first is international project. So Ibu Ismi, the next speaker, will give some introduction to our faculty and also what part that we can collaborate. So as you say that there's not only publishing papers, but also we hope really hope that our students can research in the university, maybe continue their degree to master degree, and also have some collaboration with industry. So this is also our hoping. So there are two ways we can go, the publications for sure. So we also have some, I think, linear research. If not, you can find some professors in NPT. I think there are a lot of professors in the big research. So I would like to introduce our two speakers. So Ibu Ismi Kharatin, STM TMSC. She is head of mechanical department. She is graduating from National Central University in the field of mechanical engineering. So Ibu Ismi, the time is yours. Okay. Oh, okay, sure. You can sit there. Yeah. Pakai pointer. Dua kali. Tes. Dua kali. Kalau
oh iya, enak gila. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. And this is I want to give a small overview from our faculty for Professor Shu. And this is an honorable for me to sitting here on behalf of our dean to introduce our faculty into Professor Su, so later we can have international collaboration between the Faculty of Engineering, Unisma, and also National Pingtung University. This is the overview of our faculty. Engineering faculty established in 7th of October in 1983, and then the accreditation status is very good for all of department. We have 3 departments, civil engineering, electrical engineering, and also mechanical engineering. And then our location is in East Java, and now you are here. Then this is the faculty vision and mission. We have a vision to develop the world-class engineering faculty and with a noble character based on Islam, Ahlus Sunnah wal Jamaah. And then the mission, we want to enhance the three dharma of higher education and make an impact into a society. Then to develop and disseminate science, technology, and culture for the welfare of the humanity. Also strengthen the capacity of faculty by improving good governance practice. This is our organization structure from engineering faculty. Our dean, as you know, our dean is Bu Ena, sitting beside you. And then our vice dean, first vice dean, Pak Yasa, now he is in Malaysia, so he cannot attend this seminar. And then our second vice dean, Pak Basir. Pak Basir boleh berdiri sebentar. Our second vice dean is Mr. Bashir there. Yeah. And then our vice dean of student affairs and alumni is Pak Habibi. Yeah, and the civil engineering department, head department of civil engineering is Bu Anita. Bu Anita is not here. And then I'm as a mechanical engineering department, head department. And from electrical engineering department is Pak Abdul Mutaali sitting there. Yeah, and also from informatic department is a new department for us. And Pak Fawaid is sitting there, is the head department for the informatics department. And this is our engineering faculty student body. And now totally we have 1,444 students, and around more than 50% is from civil engineering, from mechanical engineering around 29%, and 15% is from electrical engineering. And this is now our international collaboration situation. We have many collaboration with the other university. And for the international collaboration, we have many collaboration with the university from Malaysia. Actually, we do the credit transfer, and also we have a summer camp there, and also we do research collaboration with the university, several university in Malaysia. We also have a joint research with the university in Thailand and Philippines, and also we have a research. Pak Faruk have a research which is joined with the Estaka in French, yeah. And then we also have a lot of collaboration, especially for Taiwan. We already have a collaboration with some university for joint research, like National Jiangxing University, and then Sun Yat-sen University, and National Cheng Kung University. And also we have students. We sent 4 students last year to St. John University for the intense program, the double degree and also joint degree for electrical engineering student and also for mechanical engineering student. Nah, we do a lot of joint research, and also we send students to St. John University at the time. And then I want to introduce our lecture research and scope, so we can discuss about the opportunity how to make a collaboration between NPTU and also Unisma. In civil engineering, we have a hydrology, structure, construction management, and also geotechnical research scope. And in mechanical engineering, we have energy conversion, manufacturing, materials, and design. For electrical engineering, we have power system, renewable energy, industrial automation, control system, and also robotics. We have software engineering, network computation, and safety, artificial intelligence, information system management in informatics department. And this is the civil engineering research scope. It have a smart irrigation system with IoT concept. And now we have one professor, a new professor from civil engineering from this field. Then this is also the innovation of irrigation gate model, because Indonesia is have a lot of farm, so they use the irrigation gate models and others to develop in the actual application. Then this is the research from civil engineer, which published in quartile 1 until quartile 3. And this is from mechanical engineering. We have two groups. The first one is energy conversion. We have pyrolysis research and also energy harvesting. This energy conversion group are now led by our dean. Bu Ena is now leading the energy conversion group. And then the hydrogen fuel cell, thermal energy storage. We have this research group, punya Pak Faruk ya, by Pak Faruk. And then droplet combustion, biodiesel, still in energy conversion. And for the material and manufacture, we have Dr. Priagung as a team leader in mechanical engineering, and we do metal machining and manufacturing technology for using natural oil as a cutting fluids. And also we have a metal forming design and simulation, research for making a bipolar plate and designing the bipolar plate. Manufacturing design and simulation for crash box design. And also we have nanomaterial in mechanical engineering field. And usually Pak Cepi use this research by doping some material into a material, so it will get the new characteristic. Then this is the publication from mechanical engineering department. We already published several papers from quartile 1 until quartile 3. And then the last one is from electrical engineering. This is the research group. In engineering, electrical engineering, they also have energy, it's power quality and renewable energy scope, which have MPPT optimization in solar PV under sudden change in irradiation and partial shading condition. This research is below our first vice dean, and Pak Effendi. Pak Effendi also graduate from Sun Yat-sen University. And then also about the MPPT optimization in solar PV, and this is the publication result for MPPT optimization. And then using a Max PowerPoint tracker, this research due by Mr. Yasa and Pak Effendi. And next, we can continue our discussion about our collaboration, which field will we have a collaboration, and it's possible to develop between the Pingtung and also our faculty. We are happy and you are here, and then we want to have a collaboration including our student, maybe they have a possibility go there for the double degree or for the joint degree
master degree.
master program. You can explain to the student later if they have any question. And ya kalau dari saya ya, sedikit dari saya tadi yang disampaikan dari dari Prof. Su, beliau bilang kalau di Taiwan itu sekarang penduduknya decrease, jadi penduduknya sangat berkurang. Jadi bahkan orang di sana pemudanya sangat kurang sehingga satu orang itu punya opportunity di 4 pekerjaan. Jadi kalau kita di sini misalkan banyak yang tidak tersalurkan lulusan S1, di sana kamu satu orang bisa memilih 4 pekerjaan. Jadi chance-mu di sana itu ada 4 pekerjaan. Tadi juga sempat dibilang kalau misalkan di sana sekolah ada scholarship langsung ikatan kerja sejumlah itu. Jadi memang mereka dalam secara demografi memang penduduknya sangat kurang. Ya mungkin itu. Thank you for the time. Ya Pak Faruk.
Big applause to Bu Ismi. Okay. Now it's time for discussion. So first of all, I would like to students who would like to ask about maybe the scholarship opportunity or maybe get credit transfer. If you are in jika kamu masuk semester 5, mungkin ada opportunity untuk kredit transfer di Taiwan, bisa ditanyakan nanti mungkin Prof. Su akan bisa menjawab. Bisa bertanya bisa bertanya dalam bahasa Indonesia, nanti kami translate. Saya harap NPTU ini masuk di World Class University di Times Higher Education ya. Jadi sudah masuk pemeringkatan. Jadi be sure that Anda akan mendapatkan quality of education yang bagus di NPTU. Ada 2 alumni kita Pak nggih? Ada 2 alumni kita, dosen FAI. Beliau mengambil bidang education, College of Education. So, jika Anda ingin bertanya mengenai suka duka di sana dan chance to get a higher degree di sana, bisa diskusi dengan Pak ngapunten Pak. Asmani sinten? Pak Zobi dan Pak Yoyo, nggih, ngoten. Nggih. Oke ya. So, I would like to ask student first for the scholarship opportunity and also any programs that they can join to NPTU. I will let they ask first and then translate to you and then you can answer. Okay, thank you Professor. Oke. Saya buka 3 penanya untuk student. Silahkan. Oh ya, FYI ya. Kalau kerja di Taiwan, gelar S2 itu UMR-nya 40 juta. Jadi kamu bisa saving setahun setengah M lah.
40 million in Indonesia.
Ya. Dibandingkan dengan Indonesia itu antara langit dan sumur.
Tidak perlu kredit rumah 15 tahun, Pak. Tidak perlu kredit rumah 15 tahun, Pak.
Tapi harus belajar. Oke, silakan bertanya. Kalau enggak saya sebutkan, saya tunjukin nanti. Tanya apapun, misalnya saya risetnya bidang ini, kalau lanjut di sana gimana? Atau saya mau tertarik di bidang ini, kira-kira profesornya siapa? Atau nanti beasiswanya gimana? Gitu loh. Biaya hidup di sana gimana? Oke, silakan. Oke, silakan. 1. Ada lagi? Ayo, 2, 3, 4. Oke, nggak apa-apa, nanti kita buka lagi. Suwantai pokoknya. Mas yang pakai kacamata. Oke. Bahasa Jawa pun tak ladeni rek. Sepenting kue tako. Ya. Kalau bahasa Inggris malah lebih bagus, confidence. Oke, silahkan. Oh, Abu Bakar. Oke, ya. Nama, jurusan.
My name is Muhammad Abu Bakr. I'm from Sudan. I study in the Department of Mechanical Engineering. Thank you, Dr. Su, for all this information. We really got lots of new information for us. I would like to ask about the scholarship for master degree and what is the required documents for it, the requirements. Thank you.
Okay. Thank you, Abu Bakar. He is one of international students in mechanical engineering and he's quite smart. So hoping that maybe he can join to your lab. His research under my group, so he's working on the catalyst from biomass. So we characterize the elemental function and also the properties like surface area, pore diameter, and something like that. So maybe in the future, combining with your spin electronic, so the utilization of the catalyst can be more advanced. Yeah. Okay. Okay, we keep it. Okay, another one. Yang lain. Okay.
Assalamualaikum warahmatullahi wabarakatuh. Selamat sore Pak. Mungkin saya berbahasa Indonesia karena berbahasa Inggris saya agak kurang.
Gak apa-apa, aman.
Nama saya Muhammad Rosyid Kurniawan.
Yusuf.
Dipanggil Rosyid. Saya dari jurusan Teknik Sipil.
Okay.
Mungkin pertanyaan saya tadi kan untuk semikonduktor sendiri itu kan fokusnya ke elektro dan mesin ya. Untuk teknik sipil sendiri peluang kedepannya untuk kuliah di Taiwan ataupun beasiswa ke Taiwan apakah ada? Mungkin itu aja. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Oke. Oke. Lagi yang cewek ya, silahkan.
Baik, selamat sore. Terima kasih untuk kesempatan yang diberikan untuk bertanya. Sebelumnya saya Kalista dari Departemen Civil Engineering. Saya ingin bertanya, tadi kan udah dijelaskan tentang riset tentang spin. Nah, yang dijelaskan itu sendiri kebanyakan itu selalu disangkutkan ke mekanik dan elektro. Nah, untuk kedepannya sendiri untuk spinnya tersebut itu bisa berkontribusi ke dunia civil engineeringnya itu kemananya? Terima kasih.
Thank you. Ya, one more. Alan tadi ya? Oh ya, oke. Gak apa-apa, saya tampung semua. Yang elektro tadi satu. Belum yang elektro ya? Jadi ini Mas dari mana?
Sipil.
Sipil juga? Oke, silakan, gak apa-apa.
Assalamualaikum warahmatullahi wabarakatuh. Excuse me sir, good afternoon everyone and good afternoon sir. Previously, I want to say thanks for the opportunity. And previously, I'm Agio Kurnia Viraya. I'm from Faculty of Engineering and I'm from Civil Engineering Study Program. And previously, if my question, I want to say sorry if my question is the out of the box question. I want to ask for the two questions. Firstly, that spintronics maybe in the future will be useful in civil engineering or not. And secondly, that spintronics material, I know that spintronics material is not directly used in civil engineering, but I want to asking for a question in secondary that spintronic material like a smart building, like a smart interior in architect and smart building in civil engineering or not. Yes, thanks for the opportunity.
Oke, electrical. Kemon, atau informatics, saya tunggu pertanyaannya. Robotics, AI, ayo. Ini, silahkan. Ya.
Assalamualaikum warahmatullahi wabarakatuh. Terima kasih atas kesempatan yang diberikan. Sebelumnya perkenalkan diri, nama saya Hanifan Bahrun Al-Mahdi dari Teknik Elektro. Pertanyaannya cukup sederhana. Kalau kerja di Taiwan itu gajinya berapa?
Oke.
Dan kalau ikut program S1 sama
sure,
berapa
fine.
sebenarnya?
Ya. Sudah,
Terima kasih.
itu aja.
Iya.
Oke. Maybe in all levels. In all levels. Not only graduated from bachelor or master, PhD, is different levels. Okay. Another else? Oke, silakan Mas Kotir.
Baik, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
Ya. Kami di sini sangat tertarik dengan penelitian atau riset yang telah saudara sampaikan. Yang saya tanyakan, bagaimana cara kita agar tidak terlalu tertinggal dalam hal-hal seperti ini, dalam pengembangan energi terbarukan maupun strategi atau persiapan seperti apa yang harus kita ambilkan. Mungkin ada saran dari pemateri. Terima kasih.
Sudah ya? Oke. 1, 2, 3, 4, 5. Okay, Professor Su, maybe explain one question. So I would like to give some conclusion. I think the 3 question is same from civil engineering. So one question from Abu Bakar. He's asking about the scholarship requirements in NPTU. Maybe in any scheme, not only master scholarship, but also maybe joint degree program or something like that. And the second question is from the civil student. So they wonder if spin electronics can be applied in their topic. So civil had, I think, 3 big research area. First is structure, right, and geotechnic. So I think it's related to the building engineering. And the second is environment. I think water treatment and wastewater treatment, and also some water irrigation, something like that. And the third, I don't know, maybe geomatics, something like geodesy, yeah, something like that. So I think the one that related to the materials is this number 2. Okay, and the third is the question about the salary if working in Taiwan. I think maybe be honest for all levels, like bachelor, if we graduating bachelor, how much the salary? If we graduating master, how much the salary? And PhD, how much the salary? And the last question about the how to prepare ourselves about if we don't lose about the technology. So usually in Indonesia we use technology, but in Taiwan they make technology. You know, it's quite different when we use and we make. So if we want to make like technology, how to prepare, something like that. Maybe what materials or maybe like subject that we need to be more understand. Maybe about physics or chemistry or mechanic, materials, something like that. Okay, thank you, Professor Su. Time is yours.
Okay, thanks for the question from students. I think it's a good start. Okay, you have questions and then we can have more interactions. I think the first question is about the scholarship. Okay, the scholarship actually for if you apply our master degree, okay, we usually provide a scholarship, and then the scholarship was divided in 3 different levels. Okay, the third level is okay. You get free dormitory. Okay, and the second level is your tuition free, and the dormitory is free. And the top level is your tuition free, and the dormitory free, and the university also provide some scholarship. I think it's a living expense, not a big, but I think it's about 4 or 5,000 per month. 4 or 5,000 per month. Okay, it support your living cost.
NT dollars.
Taiwan dollars.
Taiwan dollars. Right.
Taiwan dollars. 3 per month.
Okay.
4,000 or 5,000 per month. Okay, it's living cost. Can support your food or some drink, and the living price in Taiwan is also reasonable, especially in Pingtung. Yeah. And of course, because you are master's degree student, so you will work in laboratory. Yes. So if your professor have some project from company or from the National Science and Technology Council.
Ministry. Okay.
Yeah, they will provide another support for students.
Okay,
For example, for my students, okay, I will support them another 6,000 or 8,000 per month. Okay, because they join our project.
Yes.
Okay, for master student. And if I have chance to cooperate with other industry, okay, and the student also join this project, this industry also support another scholarship.
Sure.
So I think all of you is good, and we also have a good relationship with some professors.
Sure.
Okay, so when you apply it, the professor or dean or president or rector, they will write a recommendation later.
How about English requirements and GPA?
For exchange students, okay, no language requirement. So some students, if you are afraid to talk English, don't worry about it. You can start from exchange students.
Sure.
Okay, then for master student application, okay, according to our Ministry of Education regulation, the TOEIC
okay.
need to higher than 550.
It's for graduation.
Yes.
So we start study, and if we want to graduate,
You need to get
pass.
the
Before entry.
Yeah,
Okay.
before
500.
550.
Okay.
550. So, but if you start from exchange student, it's not too difficult, because I think everybody English is good enough for communication, but you just need environment. You just need environment.
Sure.
Okay, so if you do not have such kind of environment, maybe you think, oh, 550 is high. But if you in this environment, you will think 550 is just good for communication. You can get the score higher than that.
Yep.
So and about the GPA, it depends, because recently in Taiwan we also encourage students to do the project-based learning.
Okay.
So sometimes the paper exam, okay, is sometimes not most important things.
Paper.
Yes, paper exam, you
paper
get
exam,
the score. Maybe it's not most important things. For example, in College of Electrical Engineering, a lot of professors has a lot of research project. Okay, you can join the research project. Okay, work with professors and then write a report. Okay, or publish some papers. Okay, it will be better. It will be better. Okay, so recently Taiwan government evaluation not only counted the GPA, but also counted another performance. Okay, that's the first question about the scholarship. But I think a lot of students get the top, yes,
Sure.
get the top one,
Yeah.
top one level scholarship. Okay, and then the second question is about the salary. Actually, recently in Taiwan, not many students want to study PhD degree because the salary for master degree student is high enough. Is high enough for them. It's higher than professor. If they work in TSM in high tech company, I think because the two professors have experience to study in Taiwan, they know. Okay, if the student get the master degree, and you are lucky because you are choose the College of Electrical Engineering. Okay, don't worry. Yeah, but my topic is not semiconductor. My topic is not electronics. Don't worry, because for the high tech company, they have a very, very good education system for freshmen, for fresh engineer.
Training. Okay.
And then the salary is high. Okay, for high tech company, okay, I think the first year, if you get a master degree, it's almost 1 million Taiwan dollars. 1 million Taiwan dollars is about
Per year or per month?
Per year. Per year.
Oh, per year.
Per year. In Taiwan, the high tech company, they count the year salary. The first year is almost 1 million. Almost 1 million. But if you work in TSMC, higher than 1 million.
Yeah.
Higher than, so most of our students, their salary is higher than me, but I'm happy.
Sure,
Okay,
sure.
I'm happy I'm happy. Okay, okay, okay. To congratulation to our students. Okay, okay. But of course, the working hour is long.
Yeah.
Honestly,
Yeah.
in TSMC, their salary is high. Is the first year is over than 1.5 million, but the working hour is from 8 to 10. 8 to 10. Yes, yes, it's common day,
Yeah.
day. But some young students say it's fine because
Sure.
they are
They don't have,
energetic.
they don't have family too.
Yeah. So, but some company, if, for example, if the year salary is about 1 million, the working hours is more reasonable. Okay, maybe from 9 to 6, or from 9 to 7. It's more reasonable. But TSMC, of course, you get higher salary,
Sure.
higher pressure. Yes, yes. But for if you just get the bachelor degree, okay, your work should be the assistant engineer. Okay, you just like the operator, just like an operator in Taiwan. So we usually encourage our students to get the master degree, because you just spend more 2 years, and then you can become engineer, not assistant engineer. And as assistant engineer, the work probably similar to operator, but you spend more 2 years, can get higher salary and more space for your future promotion. So I think more 2 years is important. For example, for our department,
Sure. Yeah.
I think more than 19% students continue to get the master degree, but less than 5 students continue to get the PhD degree. Okay, okay. So in Taiwan, if you want to become engineer in high-tech company, I encourage you to continue a master study. Okay.
Yeah. The last question.
Oh no, not the last question.
And the third
About the
the
civil.
question is about how to use the spin property for CV engineering. A very, very hot topic. I learned in a very, very hot. I learned in Europe because in the middle of this year I went to Europe for a conference. The material recycling, and the water treatment is very, very hot topic. And a lot of, if I can use computer, I can Google, I will send the information to you. A lot of startup in Europe, they focus not on semiconductor. Because semiconductor, you need very big money
Sure.
to build the fab.
Be the company.
Okay, it's not the game for young people. Okay, so for young people, the startup, they focus on material recycling. For example, the battery,
I see.
solar cell, the rare earth metal, a lot of material recycling. Okay, they have different technologies to do it. And one of my friend, okay, but he is in France. He opened a company. He work on spintronics, but he don't work on semiconductor. He don't go to the semiconductor, become an engineer. He become a CEO of a new startup for the material recycling. Use magnetic field. Use magnetic field. Why magnetic field? I think another professor already know.
Yeah.
Because the Lorentz force.
Sure.
Yeah.
Lorentz.
Because different mass, different charge.
Sure.
When you apply the magnetic field, will have different Lorentz force. Okay, so he can use the different Lorentz force
Yes.
to collect different material to do the material recycling. The similar concept can be used in water treatment.
Sure. Yeah.
Okay, for the heavy metal ion. So it's a very, very hot topic. When I joined the conference, honestly, I want to give up my research topic now. Okay, because I know the material recycling, the water treatment must be the future
Sure.
star for the research.
That's also what we do here.
Yeah.
in our department.
Yes,
So
yes,
we-
yes. It very, very. Honestly, I want to change my research. I want to totally forget my presentation.
Too many competitors, right?
Yeah,
In
yeah, yeah,
semiconductor.
yeah. Water treatment, including in Taiwan, in the future, the international politics, the supply chain.
Yeah.
Okay, so the material recycling, water treatment, very, very important. So if you do this research field, congratulations.
Sure.
Okay, it will be very good. And about the building, about the structure, I also learned from a Japanese scientist. Okay, I think he worked in Osaka University. He has a patent. He also work on spintronics, but he make a patent because in Japan they have a lot of earthquake, right? And the earthquake sometimes the rebar or the steel have some crack,
Yeah.
but nobody knows.
Inside.
Okay, inside,
Ah.
inside. So that professor they have a very nice patent. They use it because the steel, the iron, okay, will have some magnetic field, right? If the steel do not show any crack, the distribution of the magnetic field is normally. But if we have some crack, the magnetic field will have some difference from normal distribution. So he used the magnetic field to do the detection of the crack inside.
Inside the building.
Yeah, inside the building.
That's the
Inside the building. So actually, if just I mentioned, if you have new idea, will create very high value. Semiconductor is good, but I usually tell our students, okay, not only focus on semiconductor, even the TSMC is in Taiwan, but I usually encourage them not only focus on TSMC, because it's also our problem in Taiwan. A lot of professors say, if we just pay attention to TSMC, if in the future, in Taiwan, the TSMC just like
Bankrupt?
US, okay,
the US move.
TSMC need to use in other
Indonesia.
countries. If Taiwan only focus on TSMC, will be very dangerous. If we lose TSMC, will become the most dangerous country in the world. Okay, so we need to pay attention to another field.
Research.
For instance, quantum computing, as I mentioned, quantum computing is also, or the material recycling, water treatment. Okay, it's also very, very, very important. Okay, so I think that I also answer the last question, or how to make the new technology.
Sure, yeah.
I think the talk is important, because I think some professor also has experience to stay in Europe. Okay, I find, okay, they have a lot of discussion before do some research project.
Yeah.
They have a lot of discussion, why we need to do it, what is the impact of the topic, okay, and how many groups do it, okay, what is our competition to do. Because one of my students, he earned a PhD degree in France. Okay, so student is our eyes, because we need to stay in Taiwan, you need to stay in Indonesia to teach. But our student can go to different countries, be our eyes, and to share their experience to us. We can learn from our students. So sometimes I think to talk is very important. To talk with different research fields, as I mentioned. If I talk to civil engineering, okay, maybe 10 years ago, then I can have such kind of patent. Okay. Or if I talk to the water treatment expert or material recycling expert, maybe I can also have a startup, become a CEO. Okay. So to talk with different research field expert, I think is very, very important. Not only focus on your field is, I think, the first priority, but then to talk to another student or another professor is very, very important. Okay, thank you.
Thank you. Big applause to Professor Shu. So let me translate it, okay? Okay, saya translatekan ya. Untuk yang requirement untuk master degree, jadi ada 3 level beasiswa. Tapi biasanya based on, is it the any test when we apply the scholarship program? No, so it's based on papers.
Yeah, based on papers.
Application, right? Something like that. And we call the professor. We find the professor there.
If you find a professor in advance, it will be better.
Ah, it will be better. Okay. Caranya yang pertama, kamu Google NPTU, cari profesornya. Misalnya, baca paper-paper profesor yang ada di sana. Kan kita mau S2 nih. S2 itu based on research. Oke. Kalau sudah dapat profesor, apply. Dokumennya apa? Biasanya di situ di list. Ada transkrip, ijazah, paspor, dan lain-lain. Nanti Anda akan diberikan prioritas untuk beasiswa level 1. Beasiswa level 1 ini termasuk free dormitory, asrama gratis. Tuition fee, SPP gratis. Sama living cost, dikasih uang saku. Itu dari kampus. Kamu nanti dapat 2 uang saku, dari kampus dan dari profesor. Kok bisa dari profesor? Karena kamu bekerja di lab. Jadi master degree kerjanya apa? Riset. Jadi kamu doing research, writing papers, writing report, submit, reject. Nah, Anda akan dapat uang saku lagi. Besarnya berapa? Dari kampus dapat 5.000 NTD, sekitar 2,5 juta, ya Bu ya. Dari profesor dapat 6.000 NTD, sekitar 3 juta. Jadi kamu total dapat 3 tambah 2, 5 jutaan per bulan. Dan itu sangat cukup untuk hidup. Single. Kalau mau masak lebih cukup lagi. Saya dulu masak, belanja. Setiap minggu belanja. Oke, itu ya. Terus, Pak, kalau saya nggak bisa bahasa Inggris gimana? Tidak ada requirement bahasa Inggris. Cukup TOEFL Unisma lah. Tetapi ingat untuk apply visa harus pakai TOEFL. Jadi syaratnya berapa? TOEIC 550. TOEIC 550 itu, tak kasih tahu ya. TOEIC itu beda dengan TOEFL ITP. TOEIC itu standar Taiwanese. TOEIC 700 itu selevel TOEFL ITP 550. Ya, jadi itu under. Caranya gimana? Les dulu. Di mana? Nang pare iso, nanti iso les ya. Oke. Jadi IPK, Pak, IPK saya ngepres 3 bisa. Asal kamu nembak, misalnya minta rekomendasi letter dari Prof. Su, nanti kita bisa email. Is it possible to get the recommendation letter from you maybe? Yes. Based on our collaborations between university. Okay. Bisa minta rekomendasi yang mesin ke Bu Ena, Dr. Ena, bisa ke saya Bu Ismi, bisa ke sipil ada Prof. Eko, ya Bu Ita, itu minta rekomendasi. Kenapa kok butuh rekomendasi? Itu sebagai syarat bahwa kamu itu memang layak gitu loh, dapat rekomendasi. Itu penting, people in lah istilahnya gitu ya. Oke ya, itu yang pertama. Oke, jadi semua departemen bisa daftar. Oke, jadi saya harap tahun depan saya dapat WA, Pak, saya sudah di Pingtung. Wah, keren kan? Jadi gitu ya. Oke, salary. Oke, salary, kata Prof. Su, kalau kamu lulusan S1 itu setara operator. Jadi beda level edukasi. Kalau di Indonesia operator itu D3. Jadi KKNI level 6 di Indonesia itu sarjana selevel engineer. Kamu S1 daftar PLN, daftar petrokimia, daftar itu bisa selevel engineer, tapi di Taiwan tidak. Kenapa bisa? Karena S1 di Taiwan tidak pakai skripsi, jadi hanya coursework. Jadi tidak ada critical thinkingnya, karena kamu pakai skripsi, kamu diuji berpikir kritis, berpikir analitis, ya, beda SKS. Jadi kamu harus nambah 2 tahun untuk master degree. Makanya orang S2 di Taiwan kayak orang S1. 90% mahasiswa Taiwan itu lanjut S2. Ya, jadi ujiannya itu lebih serem. Tapi kalau internasional nggak perlu screening yang ketat. Ya, kalau internasional langsung go ahead. Asal dapat restu orang tua, udah berangkat. Bismillah, niat cari ilmu, jangan cari duit. Cari ilmu. Kalau ilmunya manfaat, insya Allah duit akan mengikuti. Oke. Nah, itu. Terus
pertanyaan teknik sipil. Nah, ini sipil. Sebenarnya sipil itu tidak melulu beton dan struktur, Mbak, Mas, ya. Kalau kamu open mind, kamu baca paper teknik sipil itu banyak tentang material maju atau advance material. Contoh, bagaimana kamu menyerap limbah-limbah rumah tangga, limbah industri. Itu pakai apa? Advance material. Dari apa? Sintesis dari karbon, dari silika, dari itu nanti ditambahi magnetic field, di-combine, di-doping namanya. Sayangnya yang belajar material mesin, harusnya sipil, karena gini, paper Scopus sipil itu sudah material maju. Kalau nggak percaya cek aja. Makanya kalau sipil ini nggak open mind, ya akan terus tertinggal. Karena saya sarjana sipil ngerti ini bikin struktur beton, ya itu bagus. Tapi sipil tidak sesempit itu, Ferguson, ya. Jadi sangat luas. Oke? Dan itu yang kadang kita itu underestimate gitu loh. Nah, yang sudah open mind ini mesin sebenarnya, jujur ya. Karena dibangun oleh profesor-profesor di UB itu sudah open mind, jadi kami juga ke advanced materials. Nggak hanya dulu mesin itu poros engkol, Mas. Tahu poros engkol? Engine itu loh, poros engkol. Pokoknya kalau nggak bahas engine bukan mesin. Nah, itu salah. Mesin itu luas, mechanical engineering. Nah, sekarang sudah open mind, alhamdulillah dipimpin Dr. Ena dan beberapa dosen-dosen yang lulusan UB itu sudah open mind semua penelitiannya. Jadi harapannya sipil juga open mind nih, harapannya ya, dipimpin oleh Ibu Ita terutama. Oke, nah terus tadi yang penting itu gini, karena bidang recycling, Mbak, Mas. Recycling itu yang paling hot topic itu gini, air mineral kita itu ada kandungan mikroplastik, Mbak. Bagaimana kita bisa menyerap mikroplastik di dalam air? Itu hot ini. Karena kalau di mikroskop, karena plastik kita sudah banyak. Itu kalau kita saring pakai kain, itu tersaring, tapi yang ukurannya mikro gimana? Padahal darah kita itu juga nggak bisa menyerap material plastik. Nah, mikroplastik ini jadi hot topic sekarang. How to adsorb atau nangkep. Bagaimana bisa nangkep? Berarti materialnya harus punya daya magnet, magnetic properties lah. Ahlinya di sini, Mas. Magnetic properties dari material. How to improve magnetic properties dari material. Kalau di UB ada juga ahli-ahli di bidang itu, tapi untuk lebih ke applied labnya lebih bagus di NPTU. Di UB itu ada Profesor Wardana, itu juga orang magnetik sebenarnya. Cuman di sana labnya tidak selengkap NPTU. Anda bisa langsung in touch gitu ya. Oke. Itu lalu yang terakhir, bagaimana kita agar bisa mengembangkan diri. Yang pertama, kuliah di luar negeri, Mas. Itu yang kunci utama ya. Jadi kalau kamu kuliah di luar negeri, insya Allah open mind. Kenapa kok kita tidak mencari pengetahuan terbaru? Karena kita dibatasi pemikiran kita. Ya tadi, mesin itu poros engkol, sipil itu struktur, pokoknya nggak struktur bukan sipil. Nah ini itu mindset lama ya. Padahal di Jepang sana sipil itu belajar bagaimana mendeteksi retakan bangunan pakai material maju, advance material dari magnetic properties-nya tadi. Di Cina itu sipil malah bahas water treatment pakai advance material. Cek aja paper Scopus itu banyak. Makanya Anda jangan membatasi belajar Anda. Nah itu yang pertama. Yang kedua, sering-sering ikut training, kata beliau, workshop. Sering-sering ikut kuliah tamu, ya. Atau sering baca paper. Bisa baca paper. Kalau baca paper jangan ditranslate, tambah bodoh. Baca bahasa Inggrisnya. Kalau nggak ngerti baru ditranslate, gitu ya. Itu ada tambahan Bu Ismi? Itu yang dari student. Kalau untuk dosen gimana? Bu Ena ada. Kalau untuk for our lecture, we better for first we start with publishing papers. Yeah, so in this year we have some current project. Actually, Professor Dr. Ena also had some funding from ministry. So usually we obtain funding from Ministry of Education. We also have internal funding, but I think it's limit to 50 million. It's around, I think not big, right? 45 juta itu kalau di NTT kan berapa? 50,000, around 50,000 NT dollars. I think it's quite less for Taiwan. But the thing is, we need to increase the collaboration, Professor. So we concern about our rankings, our world-class university rankings, that it is important about the papers first, and then these collaborations, you know, like international research collaboration network. If any opportunity, Bu Ena, maybe we visit NPTU this year, we plan. Because last 2 years, we visit mostly from Malaysian university, and we had published some papers with them, and we also collaborate with in terms of students competition, something like that. So this year's probably, if we got funding from the university for sure, Ibu Ena, Dr. Ena will visit NPTU with the team for sure to start about the collaboration. And is it possible for joint degree, Professor Shu? Yes. Or maybe credit transfer?
Yes, it is possible because we also have a joint degree with Thailand University. So we have experience to have a double degree. Now in our laboratory, I already have one student from Thailand for double degree. 1 year in Thailand, 1 year in MBTU. Yes.
And in which year usually students can join? Or maybe any link for us?
For double degree, in our university, we need to sign another agreement. Because they need to we need to prepare our course map to match together, and to say to write down the detail about the credit transfer, and about the right for student and the professor.
Okay. And how about the credit transfer? Like 1 semester, maybe our students can choose the good topic in NPTU for 1 semester. Is it also possible?
Yes, it's also possible. So this double degree. Double degree is more relatable.
Okay.
Okay, because the credit transfer has more is more relatable.
Okay.
Yes, yes.
Okay, so guys, there is opportunity. Jadi ada kesempatan untuk visit 1 semester di sana. Yeah. So about the tuition fee, they don't need to pay. If my students want to have 1 semester in NPTU.
Oh, for double degree student, the student only need to pay the tuition for Unisma.
Is it double degree?
Yes, yeah.
How about the not joint credit transfer?
A credit transfer the same.
The same.
Yes, yes. This means the for double degrees. I think a double degree is also good for joint research, because if the student can work 1 year in your laboratory, 1 year in our laboratory, it will be very, very nice. So I remember the double degree is just need to pay the mother university tuition, and we are host university. So our university, if they apply the double degree to study here, they need to pay the tuition to
so it's
MBTU.
Reverse, like reverse program. So
yeah. If the student, the mother university is Unisma. When he's the second year with us,
I see.
he still need to pay the tuition fee.
Okay.
To Unisma. Yes.
Okay. There is also maybe if we can have some professor for examiner, thesis examiner. So we invite maybe you, Professor Shu.
Yes, it is possible, because I also be the international method PhD thesis or method thesis examiner for France and the Czech Republic.
Bisa.
Yes, just online, so it's very convenient for
sure.
us.
Yeah. Okay. Abu Bakar ya buat aplikasi nanti. Bu Anita Perfeko. Oke. Anything else Bapak Ibu? Maybe ini untuk dosen nggih. Dosen silakan. Ada yang interested topik mungkin Pak Fawaid? Karena ini jam 3 sudah harus selesai. Sudah nggih? Nggih, sudah. So, Professor Shu, give big applause to our speakers today. Yeah. So, ladies and gentlemen, so we coming ending for our FGT today. So the point is, later. Okay, we closing statement. So my message to our students that there is a big opportunity to continue study in Taiwan, especially in PTU for you, and also a big opportunity for our lecturers to join collaborations, especially for publishing papers together. And Professor Shu from NPTU is welcoming our email maybe in the future, and also we're planning to visit NPTU in the future, this year hopefully. And thank you for coming, Professor Shu, in our campus. So enjoy the visitation, and hopefully you can safely arrive home when you go back to Taiwan. Tomorrow. Yeah, okay. Okay, so apologize if any mistaken, maybe spelling your name, so apologize. Okay. Yeah. So let's end this session. I send it back to moderator. Yeah. Ibu Ita, thank you.
Okay, thank you, Mr. Farouk. What a great discussion this evening. Thank you, Prof. Su. Okay. As we reach the end of today's event, let me thank all of you for your participation and contributions. May today's seminar and discussion bring valuable insights and progress in the field of engineering and technology. Let us close this event with a prayer for continued success on behalf of the organizing committee. I apologize for any shortcomings during the event. Thank you and see you at the next seminar. Assalamualaikum warahmatullahi wabarakatuh.